Hi chemistry lovers, I am Richik and today I am going to introduce you all with the chemistry of named reactions. We will study the brief history of developers of the reactions and the detailed chemistry of each of the reaction. Now in this first session, we will begin with the very basic and a very common reaction, the aldol condensation. This reaction will be discussed in parts and will be subdivided into concepts. So coming on to the brief history and the brief bio sketch of the developers of aldol condensation. Now we are going to look on the brief introduction. So as we can see, there are two developers involved in aldol condensation. Charles Adolph Woods, also famous for Woods reaction, and Alexander Borodin, also famous for Alexander Borodin reaction. So not only that, Woods was also famous for different ideas about the structures and also for the ideas of atomic theory. He was also an educator and a writer. But in the contribution to the aldol condensation, in 1872, Woods studied the dual property of aldol. That is, the aldol is a compound that has the property of aldehyde and alcohol, whereas Alexander Borodin was a person of music. So he also had a opera, Prince Iger. So he studied the self-condensation of pentanal and heptanal in 1869. So they had a joint contribution, uh, that is one in year 1869 and another in 1872. So this is how was aldol developed. Aldol reaction was developed. So we will be studying this aldol reaction in our next slide. So okay. Aldol reaction. What is aldol? Aldol is an abbreviation of the term aldehyde and alcohol. And aldol is such substance that has an aldehyde part and also has an alcohol part. As you can look into the structure 6. So there is an aldol. Aldol reaction is famous in organic synthesis because it is a reaction that involves the carbon-carbon bond formation. Carbon-carbon single bond formation is very special in organic synthesis. So this is all about aldol. And then the next question comes, how we can prepare an aldol? An aldol reaction can be just prepared from an aldehyde. Just you put a base in an aldehyde and you will having an aldol. So what type of aldehyde was required? Ionizable alpha hydrogen containing aldehydes. You look in structure 1, that is the acetaldehyde. Acetaldehyde, after that carbonyl carbon atom, that carbonyl carbon group, there is an carbon moiety, one is CH3. That CH3 is an alpha with respect to the carbonyl carbon group, and that has the 3 alpha hydrogens, and they're ionizable. Why they're ionizable? They can form enol like CH2 double bond COH. This is an enol moiety. We will be seeing this enol moiety later. So this is an enol formation. So these are enolizable alpha hydrogens and they can form the aldol reaction. And the product, that is 6, that is basically an beta hydroxycarbonyl compound. Why beta? Because if you look at the carbonyl group, that after that position, the bond with a bold bond and a single bond, that the carbon flunked in between the carbonyl group and OH group, that carbon is basically the alpha one and the OH containing carbon is the beta one. So if you number the carbon in an alpha beta way, so there is a beta hydroxycarbonyl compound. That beta hydroxycarbonyl compound can go for an elimination and we can get an alpha beta carbonyl compound. So basically acetaldehyde molecule undergoes an self condensation. So this is a self aldol reaction, and that on with treatment with base can form such products. Now if you look for the acetaldehyde, basically acetaldehyde number 1 is it is forming 3-hydroxybutanol, the name of the compound. Okay, there is an aldol product, and on dehydration that is forming but2-in-al. that is 7, or crotonaldehyde. That is the structure is called 7 is the crotonaldehyde. It's a famous one, famous compound. So that is all about aldol reaction. One more thing to say, that you can stop the reaction at number 6 if you put dilute sodium hydroxide, like dilute base. Okay, sodium hydroxide is general one. If you can put we can put potassium hydroxide, we can put baryta, anything. But the base, if it is dilute one, that doesn't go for dehydration. Basically, structure 6 on dehydration is giving structure 7. The carbon flanked in between the aldehyde and OH, that is having an hydrogen, and that OH that is getting eliminated, so water is getting eliminated, and we are getting number 7. So if you put dilute base, the reaction stops at number 6. But if you sometimes put excess base, or the strength of the base is a little bit higher, that can lead to structure 7, that is more common, crotonaldehyde. So this is all for concept 1. We will deal with the mechanism of aldol reaction in concept 2. Thank you. Hi chemistry lovers, I am Richik, and I am going to introduce you with the chemistry of name reaction. In the organic section, this will be the first session, and we are going to carry this session with the first and foremost reaction, that is the very famous one, the aldol condensation. We have studied this since 11 and 12 standards. This is the first part of aldol reaction. So first of all, we will be knowing about the developers of the aldol reaction. The first developers was a French chemist, a Charles Adolphe Woods. He has a lifespan of 26 November, that is the birth date, 1817 to 10th May 1884, and is known for his Woods reaction. And the second is Alexander Borodin. Borodin is also famous for Borodin-Hunziker reaction. He was a Russian chemist. 12th November 1833 to 27th February 1887. Borodin was the person who did the aldol reaction on pentanal and heptanal, and reported that in 1869, whereas Woods studied the dual property of the aldols, taking different molecules, and studied that about the aldehyde, the presence of an aldehyde group and an alcohol group, and he reported that in 1872. So this is all about the brief of aldol. In the next concept, we are going to discuss about the aldol reaction. Thank you.